Hello everyone, welcome to the class. This is the 10th video on differential equation. Okay, so in 8th video and 9th video I have discussed about homogeneous differential equation, and in today's class I will be teaching you what is linear differential equation and how to solve how to identify linear differential equation and how to solve linear differential equation. Okay, so in first video itself I have given some introduction of this linear differential equation. Again I'll do the same thing. Okay, this revision of same concept definition. I'll first discuss the definition of linear differential equation and then I'll proceed with the sums or solving. Okay, so LDE stands for linear differential equation, or differential equation of the form dy dx plus py, where p and q are constants. P and q might be constants or functions of x only. See, p and q should be constant or functions of x only. Okay, is called linear differential equation of first order in y. This is the definition. Otherwise, this equation might be like this also. Instead of dy dx, you can change this dx dy plus in place of this y you can write px equals to q. Now p and q are constants or functions of y only. Okay, you have to see this. You have to see whatever is there in denominator, you are differentiating with respect to what? Same thing should be here, p and q, either constant or the function of this, either constants or function of x. This, where p and q are constants or functions of y only. Okay, so this is the standard form of linear differential equation, dy dx plus py equals to q. And in some cases, in rare cases, you will get this also. In place of this dy dx, you might get dx dy. Okay, now before giving the example, I'll explain you how to solve linear differential equation. Okay, so solution of two different linear differential equation, it has two approaches. Since there are two types of linear differential equation, it will have a different solution and this will have a different solution. Okay, so solution for dy dx plus py equals to q is y bracket if stands for integrating factor. Now, what is integrating factor? That also I'll explain you later. Okay, first you make a note of this, proper note of this. Y into if equals to integration q if dx plus c. This is for this first type, dy dx plus py equals to q. And for second type, this dx dy plus px equals to q. This is the solution. Okay, in place of y you will have x into integrating factor is same, equals to integration q if, in place of dx you will have dy plus c. Now I'll give the example of linear differential equation and I'll explain what is integrating factor. Okay, so this is the solution. This is the standard form of linear differential equation, and this is the solution to linear differential equation. So you make a proper note of this, and then let's move on to another topic, examples of LDE. Okay, some examples of LDE. Some EXAMPL is examples of LDE, linear differential equation. Number 1. Okay, now see these two examples of these two differential equations. Okay, so our standard form of linear differential equation is LDE is dy dx plus px is equals to q. dy dx plus py equals to q. dy dx plus py equals to q. Okay, this is the standard form of linear differential equation. Now see this question, you have dy dx, so this part is there. After that plus 3y, this y is there. In place of p you have 3. So here p is equals to 3 plus 3, otherwise simply 3. Okay, and in place of q you have in place of q you have cos x. In place of q you have cos x. So this is the linear differential equation, because the definition says that a linear differential equation is of the form dy dx plus py equals to q, where p and q are constant. In this case p is constant, okay, q is not constant. And second criteria was, if it is not constant, then it should be function of x only. It should be, this p and q should be the function of x only. See, q you have cos x, it is function of x only. Okay, so p is constant and q is function of x. So our criteria is satisfied. So it is a linear differential equation. Now see this question. X square dy dx minus 2xy equals to 5x cube minus 2x plus 1. So first of all you have to keep dy dx, coefficient of dy dx should be 1. Okay, so let's rearrange this, dividing everything, this equation by x square, dividing this by x square. So you will get dy dx minus 2xy divided by x square is equals to 5x cube divided by, here also you will have x square divided by x square. Okay, dividing throughout by x square. X square minus 2x by x square plus 1 by x square. This and this gets cancelled. This and this gets cancelled. So dy dx is equals to minus 2 by xy. I'll write like this. Okay, equals to this and this gets cancelled. 5x minus this and this gets cancelled. 2 by x plus 1 by x square. Now compare this with this equation. Dy dx you have, dy dx is there. Okay, this is where is this? This is minus, sorry, this is minus. Okay, py, y is there. So this is y. In place of p you have this part. In place of p you have p is equals to minus 2 by x. So what was the criteria for p? P should be constant or function of x only. So here p is function of x only, you don't have y. Okay, so for p our criteria is fulfilled. And q means whatever is there in right hand side. Q is this 5x minus 2 by x plus 1 by x square. So criteria for q was either it should be constant or function of x only. So here we have q as function of x only, hence this is also a linear differential equation. Okay, so with the examples you must be very clear what type of equation is called a linear differential equation, what type of equation is called homogeneous differential equation. For homogeneous differential equation, dy dx should be equals to f of y by x, isn't it? You should be able to express the given differential equation in this form. And for linear differential equation, you should be able to express the differential equation, given differential equation, in this form. Okay, I'll give one more example. That is okay, so this is your another example. Okay, so given differential equation is x log x dy plus bracket 2y minus 3 log x bracket close with dx equals to 0. So let's check whether this is a LDE, linear differential equation, or not. So standard linear differential equation is dy dx plus py equals to q plus py equals to q. So let's make this dy dx form. Okay, so I'll take this towards right hand side. So x log x dy is equals to, when it goes to right hand side, you will have minus 2y minus 3 log x dx, isn't it? Now interchange the position, you have to get dy dx. So this dx I'll take down and this I'll bring this side. Okay, so it implies dy dx is equals to minus 2y minus 3 log x upon, this is bracket, okay, upon, how much is this, x log x, yes, x log x, x log x. Now what we can do is, okay, I'll split this. Okay, dy dx is equals to minus 2y upon x log x. This minus minus plus 3 log x upon x log x. Splitting the LCM. Okay, minus minus, you'll have plus here. For this, we can cancel this part and this part. Log x and log x we can cancel. Now dy dx, we have got py. I'll take this function towards right hand side because this y I need in left hand side. Okay, so I'll take this towards left hand side, not right hand side. Take this side. From there, we will have dy dx. When this goes that side, it becomes plus 2 by x log x, and y keep separately, equals to 3 by x, equals to 3 by x. So comparing with this one, here p is equals to p means the coefficient of y is 2 by x log x. So our criteria, our condition for p is p should be either constant or function of x. So function of x, we got p as function of x. So for p, criteria is matched. Now q equals to 3 by x. This is also a function of x. Q should be function of x or constant. Here we got q as function of x. So second criteria is also fulfilled. Okay, so this is of the form dy dx plus p y equals to q. Hence, this equation is linear differential equation. Okay. So one more example I'll give you one more example. After that, I'll explain you what is integrating factor. Okay. One more example I'll give you, example number 4. Example number 4. So y dy dx plus 2x equals to y sin x. Let's check whether it is a linear differential equation or not. Okay. So you have to divide this equation by y. So you'll get y upon y dy dx. Y I am dividing by y because I need dy dx separately. So I have to remove this y. For that, I should divide this equation by y. Okay. 2x upon y is equals to y sin x by y. Divide by y. Dividing left hand side and right hand side by y. Okay, this and this gets cancelled. This and this also gets cancelled. So it implies dy dx plus 2x dot 1 by y is equals to sin x. Now compare it. Here p is equals to 2x. This is p. dy dx plus py is equals to q, isn't it? 2x q is equals to sin x. See, our criteria for p should be function of x or constant. So function of x, p is function of x, it is correct. And q should be constant or function of x, this is also correct. But see this, you have y by 1 by y, it should be y only. It should be y only. Okay, here you should get y only, not 1 by y. Hence it is not a differential equation. But we have got dy dx plus q 1 by y, p 1 by y equals to q. Yes. 1 by y. Instead of this is p, 2x is p, okay, and this is q. Here in place, instead of getting y, we have got 1 by y. Hence it is not a LDE, not a linear differential equation. Okay, remember this. coefficient of y should be p, but here coefficient of 1 by y is p. So that is the contradiction. Hence it is not a linear differential equation. Okay, now the meaning of integrating factor. Integrating factor, a short form we write IF. Okay, IF means to solve the given linear differential equation, we multiply the equation by a function of x or y or both. Such a function is called integrating factor of the given LDE. Okay, so in order to solve a given differential equation, you have to multiply by a function of x or function of y. Okay, and that multiplying function is called integrating factor. And for this type of equation, for this dy dx plus py equals to q, for this type of LDE, integrating factor is calculated by this formula. Integrating factor is equals to e to the power integration p dx. Since p is function of x, here p and q are the function of x, isn't it? Since p is function of x, you have to integrate with respect to x only. Okay, and for this type of function, dy dx plus px equals to q, where p is function of y, then integrating factor will be e to the power integration p dy. This p is function of y. Okay, so you make a proper note of this also, integrating factor. Now let's proceed to the questions. Okay, see this question. Solve the following differential equation. In question, you will not be given whether it is homogeneous, whether it is linear, whether it is variable separable or reducible to variable separable. Okay, simply your question will be solve the following differential equation, and you have to identify to which category this differential equation belongs, whether it is differential equation of separable variable or reducible to variable separable or homogeneous differential equation or linear differential equation. That you have to identify on your own, and then you have to use the concept of various types, okay, of 4 categories. So first check this question whether it is differential equation of separable variable or not. Separable variable means you should be able to separate dx and x one side, dy and y another side. In this case, it is not possible to separate dx and x one side, dy and y another side. And next, you cannot reduce this to separable variable also. Third, homogeneous. You have to get y by x form, y by x form. So divide this equation by x. So x comes here, y by x, no problem. We got y by x, but this side you'll get x only, x minus 3x minus 2 by x. Here you got y by x form. For this we have got y by x. For this side we have not got y by x form. Okay, so hence it is not homogeneous differential equation. Now let's check whether it is linear differential equation or not. Okay, if you divide this equation by x, so you will get 1 by x y equals to, so it is linear differential equation. Okay, so see solution, divide this is 1, say, okay, 1 by x. So how much you will get? Dy dx, x is here, by x plus y by x is equals to 3x squared by x is 2 by x. So this and this gets cancelled, this and this also gets cancelled. Dy dx plus 1 by x y equals to 3x minus 2 by x, 3x minus 2 by x. So here p, in place of p you have 1 by x. See, you can compare with this, dy dx plus p y equals to q. So in place of p you have 1 by x, p equals to 1 by x, and in place of q you have 3x minus 2 by x. That is given differential equation is of the form dy dx plus py equals to q, where p is this and q is this. That is, it is LDE. It is linear differential equation. Now, solution. For solution, first of all, you have to find integrating factor. Now, for its solution, we find IF. We find IF, integrating factor. Okay, so IF is equals to e to the power integration p dx. This was the formula for integrating factor, e integration p dx. Okay, so I'll erase this part. Erase this part. This will be equals to integration e integration. Okay, I'll do it here. Okay, e in power integration p means how much? P is 1 by x dx. I have replaced the value of p. P is 1 by x. Okay, so e to the power integration 1 by x is log x. We know this, and value of this is x, because a log, otherwise e log a will be equals to a. This you have done in logarithm chapter. Okay, so e to the power log x will be x only. Integrating factor, we got x. Okay, q I'll note down here. Q is equals to p is equals to 1 by x. Q is equals to 3x minus 2 by x. Therefore, required REQ, required solution. Solution is what was the formula? Okay. Now required solution is, so solution to LDE linear differential equation was this. I had given you earlier, isn't it? So y into integrating factor equals to integration q into integrating factor dx plus c. So put the value, y is as it is, integrating factor if. This is if. Integrating factor is x is equals to integration q. Q is 3x minus 2 by x. Q is this, into integrating factor is x. Integrating factor is x dx plus c. I'll write later on. Okay, plus c I'll write later on. So this is xy. Xy is equals to integration, do the LCM out here. X is the LCM, 3x square minus 2 into x dx. ये दोनों तो कैंसिल हो जाएगा, ये और ये. See, look at it. See this one, q, value of q is this, if is x, and dx is as it is. This plus c I'll write at the end. Okay, so from there xy is equals to integration. If you open the bracket, you will have, okay, if you open the bracket, 3 comes out, x squared dx minus 2 comes out, integration dx. You will have this, 3 will come out, integration x squared dx. Next 2 will come out, integration dx only. Okay, so xy is equals to 3. Integration of x square is x cubed by 3. X cubed by 3 minus 2, integration of dx is x. 3 and 3 gets cancelled. Xy is equals to x cubed minus 2x. So you can divide this by x. So otherwise xy is equals to, take out x common, x square minus 2. This and this gets cancelled. Y equals to x square minus 2 plus some integration constant c. This is the required solution. Okay. Okay, so this is the required solution to the linear differential equation. You can continue with this c also. Okay, if you continue with this c, if you put this c continuously here, plus c here plus C, here also plus C, then you cannot take out common. This part you cannot do, and the final solution will be this only. This will be your final solution. You can leave your answer here, ANS answer, required solution. Okay, required solution. So you can proceed like this also. In your book you will find this type of solution. C will be kept continuously. From this required solution is YIF equals to QIF dx plus C. C you keep it continuously. Okay, don't remove C, otherwise you will get confused with the answers. Your answers will not match with the answer which is there in your book. Okay, so in order to get that exact answer which is there in your book, keep this C continuously, don't remove this C. Okay, so keep it continuously, and the final answer will be this. So you follow this process. Is this clear? So I'll give one more question. So for linear differential equation you should remember two things. First of all, whether you can express in this form or not. dy dx plus py equals to q. Whether you can express in this form or not. If you can express in this form, then you have to find integrating factor. Integrating factor is equals to e to the power integration p dx. After finding integrating factor, you should remember the standard equation, standard solution. Okay, what was the standard solution? Y into if is equals to integration q if dx plus c. You should remember these three things: number 1, number 2, and number 3. And if the function, if differential equation is just reverse of this, dx dy equals to px equals to q, then everything will change. Okay, your question is question number 2. Solve the differential equation 2x dy dx plus y is equals to 6x cube. This is your home task. Okay, so answer will be y is equals to 6 by 7 x cube plus c x to the power minus half. Y is equals to 6 by 7 x cube plus c x to the power minus half. So solve it. This is also, check it whether it is linear differential equation or not. Okay, after that you find the solution. This will be your answer. This is your home task. So I'll continue in the next class, remaining questions in the next class. Okay, thank you.